The James Webb Space Telescope has just unveiled something extraordinary and unsettling. It appears to show evidence of events that occurred before the Big Bang, challenging our long-held belief in a single, finite universe. Instead, what we're seeing suggests a multiverse, a vast, possibly infinite collection of universes where the concept of nothingness simply doesn't apply. Our universe may be just one of many, each with its own laws and origins. Naturally, the scientific community is buzzing with excitement. If the bizarre predictions of quantum physics are proven true, it could fundamentally transform how we see reality. A profound shift in our understanding of the cosmos is underway. This moment in history could be as revolutionary as the discovery that the Earth is not the center of the universe. Back then, religious authorities resisted, locking up thinkers like Galileo Galilei and even executing Giordano Bruno for supporting the heliocentric model. Today, we may be standing at the edge of a similar paradigm shift. Today, we're witnessing developments in science that challenge our faith in human reason and the true spirit of free inquiry. It's as if research is still mired in old paradigm battles, rather than a genuine pursuit of truth. Scientists often cling to outdated ideas and theories, debating their survival rather than their validity. But recent discoveries reveal that our understanding of the universe may have been fundamentally flawed. The notion that there was nothing before the Big Bang is being seriously questioned, and many researchers have suspected this for quite some time. Still, it took the stunning imagery from the James Webb Space Telescope to jolt the scientific community out of its complacency and spark a much-needed awakening. The idea that the Big Bang happened 13.8 billion years ago is being challenged. There's little evidence supporting a straightforward, linear expansion of the universe. For years, quantum physics has suggested that true nothingness doesn't exist, and from a theoretical standpoint, there's no definitive proof that the universe ever had a clear beginning, or that it will have an end. In fact, it's currently uncertain whether time itself is even real. If the new timescape model holds true, then time may be nothing more than an illusion, one we've been trapped in, shaping our entire understanding of the cosmos around it. The possibility that the universe existed before the Big Bang? It's mind-blowing. The latest images from the James Webb Space Telescope suggest, for the first time, that we might be seeing evidence of a universe that existed before the Big Bang. This challenges the long-held belief that the Big Bang marked the beginning of everything. Instead, it may have been a transition from a previously unknown state of existence. According to some visionary scientists, it's only a matter of time before we uncover more about what came before our universe. In addition, new data from the Webb telescope reveals that the universe is expanding at different rates in different directions. This contradicts the established theory of cosmic inflation so significantly that it raises serious questions about its validity. Adding to the mystery, astronomers have detected strange objects in the early universe, hundreds of galaxies that are far too old and evolved to fit within our current models. Their existence suggests that the universe's history might be far more complex than we previously imagined. With the James Webb Space Telescope, we're peering back 13.5 billion years into the universe's history, yet we find no clear evidence of a definitive beginning, no young galaxies as expected, and no so-called dark age. Despite these revelations, some scientists continue to hold tightly to traditional theories, often dismissing new data that challenges long-held assumptions. Concepts like the multiverse or cyclic cosmology, once dismissed by mainstream researchers, are now supported by increasing observational evidence. In today's scientific landscape, it sometimes seems that popularity and consensus outweigh innovation and discovery. Established schools of thought continue to push back against emerging ideas from quantum physics and modern cosmology, but the continuous stream of groundbreaking images and data from the James Webb Telescope is steadily reshaping our understanding of the universe. What's really so terrible about adopting a new worldview? Has life on Earth or humanity itself changed all that much since we discovered our planet isn't the center of the universe? Not really. The biggest impact was on a handful of dogmatists, especially church leaders, who were forced to admit they had been promoting a false narrative. For them, this revelation was threatening, as it undermined the authority and influence of the Church. At the time, there was real concern that the rise of independent science could become the new intellectual power, displacing religion. And in some ways, that's exactly what happened. Today, we see similar kinds of fierce disputes, only now, they take place within science itself. No one is executed for questioning mainstream theories like the Big Bang, but the clashes still happen, at conferences, in academic journals, across social media, and through a never-ending stream of studies and counter-studies. Are we witnessing a kind of scientific warfare? That might be overstating it, but the tension is definitely there. Thanks to advancements in technology, we now have access to much more reliable data, and it's only a matter of time before the truth becomes clearer. Many curious and open-minded researchers are hopeful that the ongoing tensions will soon be resolved through fresh telescope images. After a period of uncertainty, new revelations are likely to emerge, and we may find ourselves with an entirely new perspective on the universe. What's clear from current data is that our previous understanding of space, time, and the origins of the cosmos is either incomplete or fundamentally flawed. With each passing day, our understanding sharpens, and we could soon be on the verge of unveiling a new cosmology. The pieces of the puzzle are coming together, forming an intriguing glimpse of what lies ahead. Now, let's explore some of the most exciting new concepts, starting with the bubble bath multiverse, a fascinating idea rooted in string theory. This reality model suggests that our universe is just one of many bubbles in an enormous cosmic bubble bath, where each universe could have its own unique set of physical properties. String theory proposes that our universe is made up of one-dimensional vibrating strings and exists in a space with more than 4 dimensions. A fascinating consequence of this theory is the possibility of not just one universe, but many, each with its own time, dimensions, and potentially parallel worlds that coexist or interpenetrate. Within this framework, the idea of eternal inflation is broadened. It's no longer about a single universe expanding into an empty void, but rather about countless universes simultaneously expanding, contracting, colliding, or passing by one another like bubbles in a bubbling soup. Some of these bubbles represent regional expansions, while others are denser or compressed in specific areas. New universes, or new bubbles, are continually being formed. Some of these exist for only a short time, while others evolve into more complex structures like stars, galaxies, or even life. In this framework, our Big Bang would not be a singular, unique event but rather a localized occurrence within a larger, ongoing cosmic process. Perhaps the Big Bang marks the moment when our bubble emerged, a fleeting flash in an infinite sea of possibilities. This concept ties into cyclical universe models, where one universe follows another. Within this cosmic bubble bath, scientists have proposed the idea of the cyclical universe. It's becoming increasingly evident that the Big Bang was not the true beginning, but rather a transition, potentially from a previous universe. In Roger Penrose's theory of conformal cyclic cosmology, the universe undergoes a continuous cycle of emergence, evolution, death, and rebirth, with each new universe springing from the previous one. Here, the Big Bang isn't the beginning of everything, but rather a cosmic reset, a reboot of reality itself. This version of cosmology extends beyond a single universe, suggesting the existence of countless cyclical universes that may unfold side by side, one after another, or even nested within each other, an endless cycle of expansion, decay, and renewal. The theory finds strong support in the remarkable discoveries made by the James Webb Space Telescope, which has uncovered exceptionally developed galaxies in the distant early universe, along with massive black holes at their centers. These black holes could not have grown in just a few 100 million years, a process that would have been improbable under the old cosmological model. Although Penrose's work on cyclic cosmology, published in 2015, was met with significant criticism, the stunning images from the Webb telescope, just a decade later, now validate many of this brilliant British scientist's groundbreaking ideas. Ironically, this is precisely what makes conservative scientific circles uncomfortable, even though they were the ones who initiated the JWST mission. Many of these scientists hoped the telescope would offer proof for the lambda CDM model, the theory behind the classic Big Bang, cosmic inflation, and a well-defined age for the universe.